Hello, everybody. Thank you for tuning in. Welcome to presentation number 5 on the second part of data visualizations using ggplot and the grammar of visualization. So today we're going to be looking at all sorts of other kinds of plots that we can apply the grammar of graphics to, including scatterplots, boxplots, bar plots, line plots, and tile maps, all using that same grammar of visualizations as last week. And we're going to see how easy it is to apply all of that stuff that we learned previously with histograms to all sorts of different figures. We're going to be working with the spider data.csv dataset again. So please read the data in as last time and make sure that you have those na.strings as unknown and as blank cells. And then we're going to omit the data that's na just like last time. And of course, we're going to need our favorite data visualization tool, ggplot2. Okay, let's just quickly review the format of a ggplot using the grammar of graphics. Remember, we call the base function with ggplot, and then we add in our data with the data component. Here I'm putting in my_data. And then in our aesthetics, that's where we're actually mapping different variables to the X, the Y, the fill, all of that stuff. So we're taking spider size from my data and mapping it to X. And then in our geometries, that's where we're telling what kind of visualization we want to make. Last week, we did a lot with histograms. So here's geom histogram. But there are all sorts of things we can do, like I said. So that's where we'd swap it out in the geometries. And then finally, we have this theme component, which is where we were using all those pre-built themes like theme minimal, theme classic, theme dark, all of that stuff. If we want to change the look of a ggplot, we can do it by adjusting parameters in our different components. If we want to actually map a variable to colors, shape, or fill, we would be doing it within aesthetics. If we want to change the overall look of the geometry, we would be doing that in geometries, like how we were changing the bin width of our histograms. And if we want to be adjusting things like text, background color, font, things that carry across all sorts of different plots, then we would be doing it in theme. So it's important to keep these things separate, because if you're trying to change something within the wrong component, you will not be getting the result that you're hoping for, and you might not be able to generate a plot at all. Here's an example of the aesthetics. Here I'm actually mapping a variable to the aesthetics. So in our histogram, we see that the color is based on web type, with the 3 web types having 3 separate colors in the histogram. And here in geometries, we're bulk changing something about the histogram geometry. We changed bin width, and we're also bulk changing the color to light blue instead of having it based off of a variable like would be with aesthetics. And then here's an example of changing the theme, which adjusts the background color and plot layout using a pre-built theme. And this is theme par, I do believe. So all of those principles we learned with histograms do work for all sorts of other ggplot geometries too. And we're going to give it a try, starting off with a simple scatter plot. A scatter plot shows the relationship between an X and a Y variable, where both the X and Y variables are numbers, either numerics or integers. And here's an example of how we might build that code and how it might differ from a histogram. So we have our base the same, just ggplot function, data's the same. And now in our aesthetics function, we're adding in another component here, a Y variable. So we have X mapped to spider size, and now Y is mapped to web width, the width of the spider web. And in our geometry, we have a huge difference. Instead of it being our geom histogram, which we used many, many times last video, now it is geom point, which will help us create a scatter plot. So please give this a try, put this code into your R device, and then we're going to try running it and see how it works. So you should be getting a little something like this. Very nice. Now let's try and use what we learned last week to modify the scatter plot. Let's say we wanted the color of each dot to be based on a web type. So I want you to think a little bit about which component we would have to change to make that modification. If we're mapping a variable, is that in aesthetics, is it geometry, or is it theme? So think about that a moment. And of course, that should be in aesthetics because we're mapping the variable. So it's just like mapping X or mapping Y. We're now mapping color to web type. So please give this a try in your R script, and you should be getting something like this. So now we can see that the color is mapped appropriately. And we have our red being our orb webs, our green being our sheet tangle webs, and our blue being our tangle webs. So it's really easy to map this because it's a categorical variable. There are just 3 categories. So pretty straightforward for R to go, okay, red, green, and blue. But you may be wondering, what if we map a numeric variable to color? What if we don't just have 3 categories? What if we have infinite categories? Let's try that out. So let's try changing the colors to be a continuous variable instead of discrete. Here's an example where instead of color being web type, I'm doing it as spider size, because spider size is a numeric variable. So there are all sorts of possibilities. It's not just a few buckets. And of course, I would like you to actually copy paste the one from below, change web type to spider size, and just have these things in your R script, your notes, so you can follow along and make sure that everything is working as it should. Okay, so here we see that R actually turns your variable into a color scale. So instead of doing a few different buckets, it's instead showing that the darkest colors are the smallest spiders, and the lightest colors are the largest spiders. And of course, because spider size is also our X variable, it's just left is darkest and right is lightest. But you can see how if we chose a different variable here, maybe like web length, we would have seen more lighter colors mixed in here with the darker colors. Okay, so that is changing the aesthetic component. Now, what if we wanted to make changes to the scatter plot geometry? Like say we wanted to change the size of the points to be bigger. So of course, we do that by modifying our geometry function, just like we did with our histograms last time. So here I'm changing the size of the points with the size little parameter here. So everything else is the same. You can just copy paste. Color is still spider size. And then in the geom point, I'm just doing size equals 5. Ta-da! Now they are bigger. They're size 5. Hopefully at this point, you're really starting to get a feel for when we're modifying aesthetics and when we're modifying geometry. And I sure hope you do, because I have a task for you. I would like you to please make a scatter plot of web length and web width, where color is based on location. Okay, size of the points should be 2, and please add in the theme called theme_classic. So just some practice working with themes like we did last time. So give yourself a moment to do this. Of course, pause the video and think about it, type that up, and I will be here when you return. Your code should look something similar to this one here. My data is my data, X is web length, Y is web width. Those can be swapped around if you want. I didn't really specify which was X and which was Y. And color should be based on location. Okay, geom point, size equals 2, and finally we have plus theme_classic, which just changes the overall look. Here we go. The result should look like this. So we see the locations mapped properly. We see we have our correct X and Y, and it is a scatter plot. I wonder if you can hear that. They're mowing the grass out there. Hopefully it's not coming through too much in the microphone. Okay, we're moving on here to our line plots. Just like a scatter plot, a line plot is just showing the relationship between an X and Y variable where they're both numbers. But instead of geom point, we're using geom smooth. Okay, so just a slight difference, geom point to geom smooth, but it should give us a very, very similar type of figure. Okay. So using this kind of base code here, the only change is geom smooth, the only change is the geometry. I would like you to actually try this. Make a line plot of web length and web width, where color is determined by web type this time instead of location, and line size is 1.5. We're changing size, it's just size equals. Whether it's point size or line size, just size equals, and that will give you your desired effect. And this time I would like you to use the theme par from the GG themes package. Okay, so there are a few things going on here, right? We're changing the variables just a little bit. We're changing the geometry. Size is 1.5, and there's also this part. So I want you to practice loading in the GG themes package and using the theme par. This is the code that I did to accomplish this task. Library GG themes. If this part isn't working for you, you may have not installed GG themes on the current R program that you're using. So you may need to go into your packages, install GG themes. But if you've been following along, you should already have it on your computer. So you can just call it with library. Remember, that's like taking the book off the shelf. Install is just storing it on the shelf. Library is actually taking it off, opening it, and using it. All right, and then our ggplot function. Color is web type is the only change we made in there. And then we changed to geom smooth, size equals 1.5, and theme par. And here's what it looks like. Hopefully yours is a little less blurry than that. I don't know how that happened. But this is the result we should be getting. 3 separate geom smooth lines, a legend here, and showing that it is based off of our web type. Okay, so what if I wanted both the scatter plot and the lines on the exact same plot? Because they're based on the same variables, right? Web length and web width. So how can I do that? Well, it's actually way more straightforward than you might expect. Multiple geometries can just be used in a ggplot. We just add in multiple ones. So here's our exact same plot that we just made with our theme par and everything. And all I'm doing is slotting in here a second geometry. And it's a geom point, which makes our scatter plot. So please try that out and you should be pleasantly surprised. Here we are getting both a scatter plot and a line plot using the exact same data. Okay, very nice. Moving on to bar plots. A bar plot just displays counts for a categorical variable. That's how we're using it at this point. You can make bar plots in R that are based on the actual values, but we're not going to be discussing that at this point. It's very easy to just look that up online and swap out the geometry for the correct one, if that's what you're intending to do. But we're going to talk about bar plots that display counts for a categorical variable. And all we have to do is use geom bar. And we just need an X variable because it's just counts, right? It's just counting how many of each web type shows up in the data. Okay, using this new geometry here, geom bar, I would like you to please make a bar plot of spider family and adjust the geometry so the fill of the bars is light blue and the outline color is black. And use the theme clean. Okay, so jumping right into the practice again, we're going to make a lot of graphs. And remember, this should be calling back a little bit to the last lesson, changing the fill versus the color. So just think about that as you're adjusting the geometry and give it a go. Here's my code. ggplot, the usual x equals spider family. And then we're using the geom bar this time. Fill is light blue, color is black. Because remember, R is smart. R knows these colors. R knows what they are. And then theme clean. And here's what it looks like. Pretty cool, actually. It's such a short little piece of code, but it makes a very informative plot. I appreciate bar plots. They're nice. And quickly moving on to box plots. A box plot shows a relationship between an x and y variable, where x is categorical, just like this. This is categorical, right? Different buckets. But the y variable is numerical. So instead of this just being an automatic tally, an automatic count, this will actually be based on a separate variable. Okay, and of course, the geometry is going to be new, and here it is geom underscore box plot. So using this new information, of course, you know I'm headed right into a task. Please make a box plot of spider size by web type. Okay, and either can be on the X or Y, it doesn't matter to me. R will be able to calculate either. And the fill should be mapped to location this time. Please add the themes data. Here's my code for doing that. Here I did X as web type because I kind of like the buckets on the bottom personally. Y is spider size, fill is location. Those are what they're based off of, our mappings, plus G on boxplot, plus theme stata. Easy peasy, right? Look at that. Oh my goodness. This is what the results should be. And it's kind of cool, actually. We can see that the largest spiders tended to be sheet and tangle builders found in Yasuni, but we have some crazy, crazy outliers here for some giant, giant spiders and orb webs. So I love graphs like this as well. They're super neat to look at, very informative, and again, relatively simple. This isn't that much code, guys. It's just saying, what's our X, what's our Y, what's our color? I want a box plot, and this is the theme. Very straightforward. Okay, our next one here, tile plots. A tile plot just shows the relationship between two categorical variables. And it's kind of like one of the prerequisites for making a heat map too down the road. And all we're doing here, we need two categorical variables. X is web type, Y is spider genus is the example I'm using. I don't think we've looked at spider genus yet, so just throwing that in there. And then the geometry is geom tile. So please make a tile plot of spider family. Oh, yeah, spider family. Spider family by location. And I would like you to map fill to spider size. And please use the theme view. Go right ahead. You guys should be copy pasting experts by now. This is my code. ggplot aesthetics, X is location, Y is spider family, fill is spider size. Okay. Geom tile and theme view. Those are all of our separate components there. And what does it look like? All right. So we're seeing basically what R is doing here in our tile map is it's just only coloring in tiles where there's an actual data point that's found that has both of those buckets at once. So we do have data where Elenophiidae was found in Cocodrilos. We do have data where a Mysmenidae was found in Yanayaku. We do have data where a Symphytonathidae was found in Narupa, but we do not have an Oxyopode that was found in Papillacta higher. So it's just yes or no's essentially. And then we just threw in this little continuous variable here just to see how we can do colors and potentially make some heat maps down the line. And we're just kind of looking at what the average spider size is looking like for each of these tiles. All right. Counting plots. So this one's a little bit special compared to the other ones we were doing. And you can use it in all sorts of different cases. It's not so restricted by what's categorical, what's numerical. A counting plot just counts overlapping points. And we use it with geom count. So I almost always use geom count alongside other geometries. And we're going to give that a try over here in our practice. What I would like you to do is make a box plot of spider size by web type. The fill of the boxes should be lavender. And then I would like you to add to this basic box plot, because that's just a very simple box plot, right? We could do that. I would like you to add to it another geometry, geom count, which is just what we talked about, our counting plots. Add geom count to account for any overlapping points and color the points navy. I would also like you to please use theme minimal. There's kind of a lot going on in this one, but give it a go, give it a whirl and see what happens. I put way too much instant coffee in this drink. Give me a head spin. Okay, here's my code. A little bit longer, but nothing too crazy. ggplot, my data, as always. I wanted our aesthetics to be web type on the X variable. Y is spider size, and those could be swapped if you wanted. It's just your personal preference if you like the boxes going sideways or if you like them going up. Geom box plot, I wanted the fill of the boxes to be lavender, okay? And the geom count, which counts any overlapping points, I wanted that to be navy. And remember, when we're filling something in, we use fill, and when we're looking at lines outlines, dots, stuff like that, we're using color instead. So if you put fill here for navy, then you would not be able to see the same result that I'm seeing. You'll be a bit confused why it's showing up as black instead of navy. And then theme minimal. And this is what my result looks like. So you can see our basic box plot is there. And then what we have is all of these overlapping points. So normally in our box plot, it does show the points of data, but when they're overlapping, we can't really tell. So by adding in the count here, we see that anytime the dots are stacked on top of each other, the dot gets bigger. And that's what our n is reflecting here. Okay, excellent. So next time, we're going to be doing one more little lesson on data visualizations using a different data set this time. And in that class, we're going to be looking at how to polish our plots with advanced geometries and adjusting theme to add titles, change labels, palettes, all sorts of things. And we're also going to learn how to select an appropriate figure to visualize your data. And I hope you tune in and check that out. Thank you very much for watching. And as always, make sure to check out the reference materials in the description if you want to be following along, if you want to download the data, anything like that. And feel free to reach out anytime if you have any questions, concerns, suggestions, things you want to see me cover. And that is that. Thank you.